Cool.
Hello, Amy. How are you doing?
Hi, sir. I'm good, thank you. How are you?
Good, good. So we are doing something on trigonometry. How is it going? Are you able to do some questions from your book?
Yes, I've done them all the exercises that you've taught me. There's just this one chapter in that trig section, which I just wanted clarifying, because I don't think we've just come across that yet. So do you think I could share that?
Sure,
But
sure.
everything else you taught was yeah.
Okay, sure.
Cool. Yeah, so it's called small angle approximations. So I just kind of scanned my book just of that unit because I
Okay.
wasn't
Can
too
you
sure.
please read the first paragraph? I know you on WhatsApp, you sent me a message regarding this particular chapter. Okay,
Yeah.
so can you please read what is given on the top of it? Just
Yeah, so it says
10
you can
lines.
use radians to find approximations for the values of sine theta, cos theta, and tan theta.
Mhm.
And then it says when theta is small and measured in radians, sine theta is theta, tan theta is theta, and cos theta is 1 minus theta squared over 2.
Mhm.
So I'm guessing you just have to know that. Then
So
you can.
have they shown that why is it so? I mean, yes, you could start from here, but did they ever explain you like in the book? Because this seems to be the beginning of this chapter,
Yeah, it
5.5.
is.
Have they explained you why it is so? I think there is something about the graph. Can you please read the next paragraph also?
Yeah, so you can see why these approximations work by looking at the graphs of y equals sine theta, y equals cos theta, and y equals tan theta for values of theta which is close to 0.
So close to 0 really means that you are at this origin. Let me just mark these points for you, right? So at this area, right? This is this area which you're talking about, and for tan, it is this area which you're talking about, right?
Yeah.
So when you are very close to 0, then you see that the line y equals to theta, which is written here, y equals to theta, matches with y equals to sine theta. That's what they're trying to say, correct?
Yeah.
And for tan theta also, we can see this is kind of difficult to realize, but 1 minus theta square, the curve is given to you. It's a parabola, right?
Yeah.
Which is opening downwards kind of thing. You can see this parabola. And on the top, it is equal to almost 1, correct? Because we know cos 0 is 1 for sure. But close to cos 0 means approaching that value. It is approaching to the radian value, the equivalent 1 minus theta square by 2 by this formula. Okay, so actually you had shared with me what difficulties you are facing. I just wanted to have a look at what what is there in your book. But I think I'll begin from introducing you to this concept of limits, and then we will see what do we mean by very close to 0, right? So because you remember last year we talked about calculus, we introduced you to limits and derivatives, correct?
Yes, I do
Right?
remember that.
In year 12, we did that. So now in year 13, when you're moving, you have some concept. So I'll go back to that limit and then come back to this chapter, right? So you will get a good foundation of how come that sine theta is equals to theta for theta very, very close to 0. Is that clear to you?
Right. Yeah.
So so I have my lesson for you. We'll just work on that. So let me just share the screen. Okay, so my approach will be slightly different from what we have seen here. But to begin with, I have the same things which you showed me, which is we're talking about small angle approximations, correct? So when the angle is very, very small, then sine theta approximates to theta, tan theta approximates to theta, and cos theta approximates to 1 minus theta square over 2. And always remember, we're talking about the angles in radians, right? Not in degrees. Radians is a default unit, and we are working with angles in radians. Is that clear to you, right?
Yes.
Some more equations which we have not dealt with so far are written here. I'm writing value of cos theta. It could be written as a series. That's cos sine theta and cos theta. You can make a note of this series. Sine theta is equals to 1 minus theta cube over theta 3 factorial. When I say 3 factorial, it means, let me write what n factorial is, right? So n factorial is basically product of numbers till n, right? So you can say 1 times, 2 times, 3 times, 4 times, right, till n. Is that okay?
Yeah.
So product of n numbers 1 to n is n factorial. So when I write 3 factorial really means one. I could write also decimal here. That is not a decimal, but a sign for product, right? 1 times 2 times 3, which basically is 6, right? So that is what 3 factorial is. 2 factorial, if I write, it is 1 times 2, which is 2. And if I write what 5 factorial, for example, then it could be written as uh, 1 times 2 times 3 times 4 times 5, correct? And 4 times 5 is 20. 20 times 6 is 120, right? So we could, that is the convention. So sine theta is 1 minus theta cube over 3 factorial plus theta to the power of 5 over 5 factorial. Similarly, cos theta has a value of 1 minus theta square over 2 factorial. So these are the series which gives you approximate value of sine theta and cos theta, right? We're talking about approximate values. We will look into the binomial expansion and the special usage of binomial expansion to get the values of sine theta and cos theta. That will be a different chapter. However, this will be dealt with in that chapter. Is that clear to you? But it's also a part of your curriculum, and that's why I'm just giving you here, okay? Now, as I was saying, we'll actually get into the concept of limit, because the thing is, when we say small angles, what does this small angle really mean? When we say small angle, that means what? Well, I could say, well, theta is approaching 0. You get the idea? Small means very close to 0. Is it clear to you?
Okay.
Very close to 0. You will be surprised, however, that the value for cosine, the theta could be pretty large also, will give you a value which is close to 1%. Right?
0.
So, yeah, close to, not theta approaching 0. Even theta equals to, in degrees, if I say, this is in radians. This theta is in radians, but in degrees, almost about 30 degrees also, if you choose this radian value.
Yeah.
It will be pretty close, within 1% error.
Oh.
We'll learn that. Right. So it is not just approximations, a very accurate approximation, many times used for many results. And when we are saying theta very close to 0, think like this. If you're looking at planets, right? If you're looking at planets very, very far away, like things like this, right? So you're looking at a very, very small angle. You get the idea. This angle is in minutes, is not even in degrees.
Yeah.
Because the distances are far.
Right.
So when the distances are far, we're looking at very small angles. We could approximate sine theta to do our calculation. Tan theta to theta to do our calculation. You get the idea?
Yeah.
So the approximation is so accurate
that
we can actually get fairly good results from those things. Is that clear to you?
Yeah, because when you hear approximation, it seems like it's just like a wild, educated guess, but it's actually quite accurate. Yeah.
Quite accurate. Now, what I've done here is, we saw some graphs from your book, but fortunately, I have very different ones. The approach is slightly different here. So what I've done here is, I've shown you a graph of y equals to x. Do you see that y equals to x graph right in the middle, right?
The red one?
Red one. Now, if you look at this part, then tan theta and sine theta are both equal to x. Do you see that? Fairly equal to x. This is very enlarged, as you can see. This portion is like overlapping. Is that correct?
Yeah.
But as we move along, you will notice that tan theta is closer to x sine theta is closer to x than tan theta, right? Second, you also realize,
does that mean that sine x the approximation is much more accurate?
Yes. So the percentage error for sine x will be lower.
Right. Yeah.
Than for tan x.
I see.
For the same value, let us say we pick up a value which is close enough. Let's say radian value here, right? Yeah. Around 1 degree. Let us say 1 degree, right? 1 radian. 1 radian if I pick up, then see. For 1 radian, the percentage error for sine will be very small as compared to tan, because we are actually taking the x value. Is that clear to you?
Yeah.
What you also see is the tan value actual is higher than the x value, and sine value is lower than the x value.
Yeah. So none of them are actually on the x value. That's why it's the approximation. Yeah, okay.
Right. But x is kind of mean somewhere in between, correct?
Yeah.
So all these things you can visualize from here. Now,
Yeah.
in today's lesson, I'm only giving you an idea of what is a small value and how do we just calculate. In the next lesson, we'll talk about percentage error in calculations and how much close can we go to the radian zero value. Is that okay?
Yeah. Just
We'll
a
talk
quick
about it,
question.
yeah, percentage error in the next class. But let's try to understand the approximation itself, how accurate the approximation is, and the type of results which we are getting. It's good to visualize that tan
Mhm.
theta value is higher than the approximated value, but
Right.
sine theta actual value is lower
Lower.
than the approximated value, right? Because the
Right.
x is right in the middle of almost is in between sine and tan. Is that clear to you?
Yeah.
Hmm?
So just a quick thing. So with the cos theta graph, are you not drawing it on there because it's different?
Yeah, it's different. I'm not
Okay.
drawing on that. I should have drawn. But what I'm trying to do is like sinusoidal functions, when I discussed with you, I said sine is my main curve, correct?
Yeah. Yeah.
Cosine is a translated sine. Cosine is a translated sine. It's shifted, correct? 90
So
by
yeah.
pi by 2, correct?
Yeah.
So at 0, cos theta is 1. The value of cos theta is 1, correct?
Mm.
As you had seen in your book, this is a parabola, right? Inverted parabola, right? So if you draw this curve, I mean, I need a different, because for cos, I need at 0, I mean, you get the idea. For the cosine, the function will be kind of like this. Is that clear to you? Very different from tan
Yeah.
and sin.
Yeah. So there's no
Um,
point drawing on that curve.
Yeah, so it is
Yeah.
it's a separate story altogether, right? So
Right. Right.
I thought I'll not mix and match.
Okay. Cool.
So
Yeah.
I'm just
That's
focusing on
very.
sine
Yeah.
and
The
tangent.
way you drew the graph is quite clear to see. You know, the difference between sine x and tan x, and seeing the percentage error between them. Yeah. So
Correct.
that's
So
really
let's first
clear.
appreciate sine and tan, correct?
Yeah.
And
Yeah.
my interpretation to cos is, I say cos is a function of sine.
Yeah. So they're
And
basically
I
the
will
same.
derive this formula of cos from sine. You get the
Right.
idea.
Right. Yeah.
I'll derive this
So
formula of cos from sine.
if I found a value with sine, let's just say, can I find the value of cos just by shifting?
Yes.
Okay,
Yes.
cool.
You can definitely, right?
Yeah,
Because
yeah.
both are related. And I'll show you how. I will show
Okay.
you how okay, let's see. So first I'll talk about the concept of limits, and then we will see how to prove that sine theta is approximately equal to theta and both are equal to theta, right?
Yeah,
You can
yeah.
see this portion, right? Both are.
Yeah,
And
overlapping.
you can now appreciate that tan theta is actually higher than the value estimated. Sine theta is lower than the value estimated. Perfect. Then we will prove that cos theta is equal to 1 minus theta square by 2. We'll prove it.
Okay.
So we'll start
Like
from
that.
here. We'll prove other things, right? We cannot
Yeah,
start
yeah.
with so many assumptions. That is what I thought, right?
Right,
If I
right.
give you these are the formulas, now apply and get the result, there's no fun in it, right? How did you arrive at the
Yeah.
formula is more important for me as a mathematician or a math student of grade 11 or 12 or 13, right?
Right, right.
Right, because we are not into like just this is the formula, apply, get the result. No.
No.
How did we get there? We have to understand. Then we will take some examples, small angle approximation examples, which are similar to your book, which I just saw, right?
Okay.
So is this clear to you?
Yeah. Right.
And this is something which good to know. So I'll say plus, correct? Good to know, not required now.
Okay.
We'll need it after 2-3 lessons. Okay. Once we cover the binomial theorem.
Oh, I see.
Yeah, it's connected. Everything is connected. So I'm taking to calculus now.
That's what I love. Connections.
Because trigonometry is such a vast, it's a foundation for many higher level mathematics things. So
I can see it creeping up in every topic.
Yeah. So we have a connection with binomial theorem
trig.
series. You see that series, right? Approximations. And this trigonometry is with calculus, correct? So it's very well connected. That's why we'll understand it all, but in steps, small steps.
Steps, yeah, baby steps.
So the graph which I have drawn is not the cosine graph. Let me tell you now, this bell type thing looks like your cosine graph in the book. No, this is not your cosine graph, okay? Not your cosine.
Oh.
It is my
but it starts at 1.
sine theta over theta function.
Okay.
So this is the graph of sine theta divided by theta. Is it okay? Sine theta divided
even
by
though it
theta.
starts at 1.
It looks like that, right?
Yeah.
Now it makes sense because you said approximate value of sine theta is theta, correct? So if I divide sine
Right.
theta by theta, I get 1, correct?
Oh.
So that is my
Yeah.
1. That is my 1. Sine theta
see.
divided by theta has to be 1, correct?
Yeah, yeah.
So sine theta
Because
divided
we
by
said
theta.
sine theta equals theta. Yeah, approximately. Yeah.
If the angle is small, correct? So it is only 1 in this band. Do you see that?
Oh, nowhere else.
What you see, otherwise it is lesser value. Theta is higher. So it makes sense.
Yeah.
We had a graph which was kind of like this, right? This was x, right? So let me again draw with the red ink so that you understand. We'll keep following that. And I think that one was green. I don't know what was
The
it?
white, the sine x is green.
Kind of like, you see that sine x? This is sine x.
Yeah.
Correct? So it makes sense, that picture, the first one, x.
Yeah, very clear.
So you may call x or theta if you want to. Theta and x is the same thing. Only very small, it is 1, correct? Otherwise, sine x is lower, and therefore you have a value. This ratio is lower. Do you see that lower ratio?
Yeah.
It could be anything. I mean, it's not,
Oh.
they are not equal. They are only equal in a very small band. This is what I'm trying to show. Is that clear to you?
Oh, okay.
And the concept, very close or very small, comes from this concept. It is only when we are approaching to 0. Do you see from left side and right side? When you approach, then the value sine theta over theta approaches 1, and then sine theta equals to theta, right? So that means now sine theta equals to theta. I can cross multiply, right? When theta is approaching 0. Is that clear to you? You're back again. I think now your Wi-Fi is fine, right?
Yes, hopefully.
Okay, you can see the screen.
Yes, I can.
So we were here, we're talking about ratio of sine theta and theta, both measured, theta being measured in radians. As you can see from the graph, when theta is approaching 0 from both sides, left or right, in that case, sine theta over theta is 1, correct?
Yeah.
So that basically means that sine theta is equals to theta when theta approaches the value 0, correct?
Right.
So that is what we have come to. Now, how close, you can see from here that only a small band, which is very, very close, which I've highlighted in yellow, is the portion where it is approximated sine theta and theta same. But if theta is slightly more, then you can see that sine theta value is much lower, right?
Right.
As we had seen in the very first graph, y equals to x is slightly above y equals to sine x, correct?
Yeah.
When we are talking about small angles. Now, in limits, what we do is that we approaching means, let us say we want to approach a value 0, 0 from left side and 0 from the right side. It really means that minus 1 to minus 0.1, minus 0.01, minus 0.001 means getting close from the left side, correct?
Oh, okay. Yeah, closer to 0.
Moving from the right side, you can start with 1, for example, and then move towards the closer to 0, means test the value of sine theta at 0.1, test the value of sine theta at 0.01 and 0.001. What do you get, correct?
Yeah.
So if you calculate this value, sine x over x, for these values of x given in the table, then the column shown here is approaching from the left side.
Oh. And it
The
gets,
column shown here is approaching from the right side. Clearly, 0.9999 means they are approaching 1, correct? From both the sides.
Yeah.
Perfect. So
yeah.
I cannot divide by 0. When I have sine x over x and x approaching 0, it cannot be 0, correct? I cannot divide by 0. We're talking about approaching means very close to 0. You should understand that part, right? Yes, sine 0 is also 0. It is true. But we cannot write sine x by x at 0 because the denominator cannot be 0. Perfect?
Right.
So we use this nomenclature, approaching 0, very, very close. So at this stage, sine x is equals to x, and that was your approximation. You have understood how and why do we have this approximation, correct?
Yeah, really clear.
Absolutely, you're right. Now let's see about the tan x. We know tan x will be slightly more than x from the graph we just saw it. But now let us see how exactly we can, derive it. So here what I've done is that I've taken a segment AB. This is my segment AB. Now made a right triangle ABC. So in this particular case, I have a right triangle angle 90 degrees at B, right? So angle B is 90 degrees.
Mm-hmm.
So my triangle ABC is a right angle triangle. Clear?
Yeah.
So in that right angle triangle, what is tan theta equals to? If this theta is a very small angle, then tan theta is the ratio of opposite side to adjacent,
Over
correct?
adjacent. Yeah.
And clearly it is BC over AB, correct? Now, if the angle is very small, then this arc, which I have shown in red color, BD,
DB. Yeah, BD.
it will be same as BC, correct? It will be same as BC, because if the angle is very small, then they will overlap, correct?
Oh, okay. Yeah.
What is arc? You just learned arc length is R
Is R
theta.
times theta.
R
Yeah.
here becomes AB, correct? So AB times theta is the length, arc length BD, correct?
Oh.
So
Yeah.
that means this arc length BD is same as BC. So I've written that this arc length BD, which is AB theta, because the radius for this arc is A to B distance,
Yeah.
correct? So AB theta is basically equal to, AB theta is basically equal to the opposite side BC, correct?
Yeah.
Now, what is the ratio BC by AB? Just divide BC by AB, you get theta. So BC by AB is theta. That really means that tan theta,
Tan
which is
theta.
BC over AB, is approximately equal to theta when angle theta is very small. Do you see that?
Oh, yeah, yeah.
Clear?
That's why I actually before I even knew this, when I was doing on my calculator, because it's in radians now, when I do tan of like 0.26, my value is also like 0.26 something. Yeah, and I'm like, why is that happening? But I thought it was just coincidence. I should have questioned it. Now it makes sense. Oh, okay.
Clear?
Yeah, and it didn't happen with cos, only sine and tan.
With cos also it will happen. You didn't notice, but it will happen.
Oh, it does?
Yes.
Oh, right.
So
okay.
you clearly see that tan theta is also equals to theta.
Yeah.
We earlier derived sine theta equals to theta. Now we are saying tan theta equals to theta. Both are same, right? Almost same. You know, tan theta is slightly more than theta, sine theta is slightly less than
lower,
theta, but they are almost same. Now, we could also approximate this longer length AC to AD, correct? Because the theta is very small, as we approximated the arc to BC. Now, if I approximate that, that is the hypotenuse we are talking about. Do you see that? So opposite over hypotenuse, which is the sine theta, right? BC over AC, which is sine theta. Now, if I'm saying A to C is same as A to D, right? Which is same as A to B, right?
Yeah.
So it which is same as tan theta. BC by AB, correct? You
Makes
get the idea.
sense, yeah.
And therefore, sine theta and tan theta both approximate to theta.
That's clear. Yeah, it's good to see how it was derived. Yeah.
So it is from this particular side that when the angle is very small, the arc length is actually equals to the linear length between those 2 points.
Oh, got it. Yeah, yeah.
And when these 2 points are supposed to be same kind, hypotenuse, it doesn't matter, right? Whether you take this distance or that distance. So tan theta and sine theta become same, right? So that is how we derive it. Now let us get back to cosine theta and understand how cosine theta's formula is derived, which is 1 minus theta square by 2, because it's very different from tan and sine results, correct?
Yeah, yeah.
So let me take you to the trigonometry of compound angles. In that, we learned some formulas, right? So we had the formula of cos A plus B, which is cos A sine B, cos A cos B minus, sorry. cos A, cos B, minus sin A, sin B. And from there, if I put A and B as same, if I put A as equal to B, so I get cos of 2A. If I write B equals to A. So we get what? We get cos, I'm writing B as A, so it gives cos A times cos A minus sin A times sin A, correct?
Yeah.
That gives you cos square A minus sin square. Now, you could write cos square A as 1 minus sin square A. And you have here sin square A. So you get the formula 1 minus 2 sin square A. This is a standard formula which you also might remember. So we say cos 2A is equals to 1 minus 2 sin square A. So that is where I'm beginning from. Cos 2x is 1 minus 2 sin square x. Okay?
Yeah, yeah.
Now, if I substitute 2x as equal to theta, that means x is equals to theta by 2, right? If I do the substitution, I get cos theta. I'm substituting instead of 2x theta is equal to 1 minus 2 sin square instead of x theta by 2. You see that?
Yeah, yeah.
We just derived, which I sin square theta by 2, I could write like this to be more clear.
Yeah.
We have just said that sin theta is what? Theta, right?
Yeah.
When theta is very, very small, let me write like this, as compared to 1, we're talking about radians. In
Sin
that
theta.
case, sin theta is theta, so we get 1 minus 2 theta by 2 whole square, which is what? Theta square by 4, right? You could write this as 1 minus 2 theta square by 4, correct?
Yeah.
And then you
Then cancel
2 and 4, you get theta square by 2, which is the formula for cos theta. Is that clear to you?
Right.
So that
Yeah.
is why I'm not giving you the graph for the cos theta, but I'm just deriving the result from what
Yeah.
we just derived. Make sense?
Makes sense. Yeah.
So this is your cosine approximation. Now you have understood all this. Let's take some examples. So what I did was I took multiple choice questions, it'll be easier for me to explain. So can you please read the first question?
Yeah. So given that theta is small and is measured in radians, use the small angle approximations to find an approximate value of expressions from question 1 to 4.
Correct. So we have 4 questions. First one, tan 5 theta minus sine 2 theta over 2 theta should be approximated to which value? Let's calculate. Tell me. Tan 5 theta is 5 theta, right?
5 theta
Minus 2 theta,
2 theta.
Divided by 2 theta, correct?
So 3 theta over 2 theta is 3 over 2. B.
So simple. Do you see that approximation chapter?
Yeah.
Very simple. Now, question number 2, but it's important to understand this one. Above thing is same, right? We'll just repeat.
So 2 theta plus theta minus 1 minus 2 theta squared over 2.
Correct?
Yeah. So we need to simplify.
Right. So you have to remember this, right? So make a note of the formulas because this cos theta formula is theta square over 2, 1 minus theta square over 2, correct? So we substitute this value, which is, let me write down here, right? Cos theta equals to 1 minus theta square by 2, right? So in this case, theta is actually 2 theta. That's why we are putting theta square by 2. Is it okay? So it is 3 theta minus, when you open this bracket, it is minus 1 plus 2 theta square means 4 theta square, correct? Over 2, correct?
Over 2. So that's 2 theta squared.
So what do you get?
So 2.
So actually it was a product. I'm sorry. This was a product, not multiply. This is product. This was not plus. It is a typing error.
Oh, sorry. Okay.
So this is 2 theta. Sorry. 2 theta square. Is that clear to you?
Yeah. Oh, so it's minus. No. So 2 theta squared add 2 theta squared is 4 theta squared. Oh, but is that subtraction for a whole? Oh, okay. So the answer is minus 1.
Yeah. Minus 1. There was a typing error. It is product of sine 2 theta and tan theta minus cos of 2 theta is what, correct?
All right. Got
Yeah,
it.
typing it. So that is what you do, and you get -1 as your result. Clear?
Yeah, yeah.
Yeah, this one. Third.
So
1
1
yeah.
minus, then in brackets, 1 minus 2 theta squared over 2, divided by 2 theta times 3 theta. So 6.
So 1
theta
minus
squared.
1 is 0, right? That becomes plus 4 theta squared by 2, right? Divided
Yep, so
by
2 theta squared over 6 theta squared,
correct.
which is a third. D.
Clear?
Oh, yeah. So you just need to know your formulas.
Yeah, that is all. So once the formula is given to you, the exercise, there's nothing in it. You get the idea.
Oh, yeah.
That's
But it's
why I
nice to
was
know
just saying,
how it, yeah, because when you taught me how it derived and all the graphs and everything, obviously, because this is quite, so far, like kind of easy topic, like you said, you just need to know your formulas. But when it comes to the exam, because everything comes in one go, it's so easy to forget this. So knowing
yes.
where it comes from is really handy. Yeah.
And remember, in the exam, this will not be an independent question. Before this question, they are going to ask many where
yeah.
you need to understand the concept. They
Um,
say first find the arc length. They may start from there, and then they
Yeah.
will say, what is your percentage error? They're
Right,
going to
right.
connect it.
Yeah.
But the part which you wanted to know is this, which directly from the formula is so simple. Well,
Yeah.
in this case, I've just shown you the calculations. 1 minus cos 2 theta over tan 2 theta sine 3 theta really means 1 minus 2 theta whole square divided by 2 divided by 2 theta times 3 theta as we did, and you get the result 1 over 3, and that is the right answer. Clear? Simple.
Yeah.
But that is how you have to do it. Remember that when we are approximating, then sine theta is approximately equal to theta, tan theta is approximately equal to, you can write this, theta, and cos theta is approximately equal to 1 minus theta square by 2. Clear? Now, last question, where we had just 4 of them. Okay, so last question here is 1 minus 4 cos 4 theta divided by this. Can you quickly do it?
So 1 minus 4 times 1 minus 4 theta squared over 2 over 2 theta times 3 theta.
Correct.
So need to simplify. 1 minus, so that's going to be 16 theta squared times 4, 64 theta squared.
So we have,
I think it times by 4.
oh, sorry, there was 1 minus here also. Sorry. There was 1 minus, right?
Oh, yeah.
Right. So that 1 and 1 will cancel. So we get plus, correct?
Yeah.
Sorry. Okay, so 2 times 6 theta square, correct? So 1 and 1 cancel, we get 2 times this, 3, you could divide, right?
So 32 divided by 6, 4/3.
Yeah. Is that clear to you?
Yeah.
So that is how you have to do this unit. So we'll end here for now. But I hope you understood the concept. The whole idea here was to understand the starting point itself. That is small angle approximation. How do we get there? So sine theta is equals to theta when theta is very small. You could see that if I actually calculate the value of sine theta over theta, so the whole idea is that the value of sine theta over theta
equals 1.
Equals to 1 when theta approaches 0.
0.
That is what we say when theta is very, very small as compared to 1. This is the base. Right. So we calculated literally, substituting the values of theta from, let's say, minus 0.001, correct? And then also check the 0.001 plus side, both sides.
Plus side, both sides, yeah.
And we approached to a value which was very close to 1. And you saw that graph which looked like this. So only at very close to 0, it was 1, right? So that is the foundation. And then for the tan theta, we had that arc, correct? So we had that arc which gave you the concept. This is the arc, right? So, and if I kind of extend it a bit, further, I mean, you understand. So if make a right triangle, then the arc length is as good as the length of the opposite side, and therefore tan theta becomes equal to theta, and even the hypotenuse approaches the actual length, which is base, right? And therefore theta approaches theta, and arc length A equals to r theta. So that is the formula which we use to find these results. Is that clear to you? And then using the cos 2 theta formula, we derived what this is when theta is very small, correct? So that is how we did all these, approximations and got the result. Applying these results to the questions is not very difficult. You can substitute and get the result. In the next lesson, we'll talk about the percentage errors, and we'll also see which are good angles. Up to what angle should we really apply this approximation? And if we want to work within tolerance of, let's say, 1%, right?
Yeah.
In that case, what could be the maximum value of angle theta, right?
Oh, I see.
That is the type of question which we'll look into next. Is that clear to you?
Yeah, sounds really good. So yeah, I think I really understood this concept.
Right. So I'm going to end the class here, but I'd like you to kind of conclude what you have learned and summarize our learnings today.
So yeah, like I saw when I shared in my book, it kind of just started off with the formulas and gave a couple graphs. But like you said, so I think it was kind of starting at the end, and I kind of needed a bit more, but there was nothing else in my book. It was just that, and that's where it starts. So I think giving all that background on how those three formulas are derived, and especially how the graphs look, because that was really clear to see. And using that sin x, so like you said, when subbing in those values, I don't think you can get it any more clearer than that. When you start at, like we said, 0.01, just getting smaller from both sides and seeing that eventually you're getting 0.99, it is 1. That's as close as you can get it. So therefore, using that when it approaches 0, sin x over x has to equal 1. And so that's where when you cross multiply, sin theta equals theta, or vice versa. So we saw the same thing with the tan graph. And then cos, I'm glad you didn't graph it on the same one, because it is a different graph. But seeing how it was derived was really clear. And just making like b equals a and working with that. I don't think I've come across that formula before, but when I do, at least I know I've seen it now. So that's really good. So yeah, it's just those three formulas. And then when we work through examples, it was kind of just using that concept and then subbing in different values of theta. So it could be 2 theta, 3 theta, something like that. Just sub it in. Yeah. And then get your answers.
Perfect.
So,
okay, then. That's great. So try all the questions from your book. And then let me know. Next time, as you know, we'll do percentage error in these calculations. That'll be interesting, actually. Okay, great.
Cool. Thank you so much.
Have a good day.
Have a good day. And you.
Yeah.
Bye.